Hello and welcome to an episode of today's session for AP Physics C. I almost said AP Calculus. In this video we'll be covering vectors and specifically cross and dot products. So the dot product is, dot equals scalar product. And that is equivalent to, if you have a vector A and a vector B, the, A times B times cosine of theta. And then you have your cross product, which is your vector product. So in this case, it equals A times B equals A B, sine of theta, where theta is the angle between the two vectors. And this should really be, there shouldn't be a multiplication there, so that ignore that. And then we could say that equals A dot B. Okay, so let's get into this. So by the way, so this, since it's a scalar product, it will not have units, whereas the vector product, the cross product, will have units. Okay, so the best way to kind of understand cross and dot product is simply by doing practice problems. So this is what we'll go ahead and do here. So we'll start off with some basics, just not even like cross or dot products, just simple, vector either like addition, just vector rules or whatnot. Okay, so we have 2a, so 2 times vector a equals 2i, and so the I unit vector is equivalent to like the x direction. So I'll just put the sub what it's normally would be called in like common terminology up on top of it, but normally you wouldn't do that. It's negative 9j. This j is y, and then plus 6.2k, where k is z. Okay, and it wants to know what does a equal. So we know that 2a equals this, so all we have to simply do is just divide by 2. So we get a equals, sorry, that was a mistake. So a equals I, so 1i, because 2 divided by 2 is 1, minus 4.5j, because negative 9 divided by 2 is negative 4.5, plus 3.1k, because 6.2 divided by 2 is 3.1. Okay, the next question wants to know what negative a equals. So we have a equaling this. So if we want negative a, all we have to do is multiply this side by negative, because we're multiplying that by negative. So this turns into negative I, this turns into positive 4.5i, and then this plus right here turns into negative. So it's negative I plus 4.5j minus 3.1k, and that would be equivalent to negative a. The last question wants to know what the magnitude of a is. So pretty much like how big a is. And to solve that, our resultant for a 3D vector equals the square root of, I'm going to put this as an x, y, and z, but just remember x equals I, y equals j, and z equals k. So equals x squared plus y squared plus z squared. So if we go and head over to our calculator, I'll just add calculator. Hold on. I actually might have to, well, that is quite odd. My calculator application doesn't seem to want to respond here. I'll pause the video real quick and, oh wait, okay, we're good. So I don't have to do that. Okay, so once the magnitude of a, so if we remember, if we go ahead and do the square root, so we'll go ahead and get that. So our, we had 1 as our I, and that's x, so 1, and then I'll just do squared, plus, even though 1 squared is still 1, 4.5 is so we know that if we I'm going to quickly go back to this. We know that it's negative 4.5 just for the value of a. This of course is negative a, but it was negative 4.5 for the value of a, but since that value is being squared, we can just write 4.5 squared because it will turn into positive in the end, and negative 4.5 squared is equivalent to 4.5 squared. So we're going to go ahead and add that to 3.1 squared, and we will get a resultant of 5.56 units. And this particular problem didn't give us any units, so we would simply write 5.56 units. And I'm just rounding to 2 decimal places, just for convenience sake. Okay, so the next problem says C equals 38, comma 310 degrees. Okay, so this is pretty much saying vector C has your first law in this. Sometimes with 3D, so with 3D vectors, you have your magnitude, comma, angle, so I'll just call that theta, and then comma tilt, so tilt, angle. So that's that notation for that. But we see that this doesn't have a tilt angle, so we know that that's a 2D vector. So it has a magnitude of 38 and an angle of 310 with respect to 0 with respect to the positive x-axis. So it's like it'd be 310 degrees, so like somewhere like right there or whatnot. So to solve for C, it wants the components of C. So we know that 310 is our angle, all right? So to find the, we'll just do we'll do y component first. So sine of theta equals opposite over hypotenuse, right? We know the hypotenuse is 38, so thus the opposite, which is opposite equals y. So the opposite, which is also equal to y, equals h sine of theta. But so like right now we can solve because we have our h. That's our hypotenuse, that's our magnitude, 38. So this equals 38 times sine of theta. Theta is 310 times sine of 310. So if we go ahead and check that on the calculator, just making sure I'm in degrees real quick. So 38 times sine of 310 yields us, I have to change my settings real quick because I haven't changed on my actual calculator. But I do not have them changed on here, so excuse me real quick. I need to make sure that it approximates. Here, I'm gonna oh, here we go, found it. Approximate, make default. Okay, sorry about that. But if I go ahead and quickly copy that and then paste it down here, we get negative 29.1. And since this is a vector and this is AP Physics C, we need to write that in vector notation. So negative 29.1, I'm just going to call that one J unit vector, okay? So that's our J, and then to solve for X, we essentially do the same thing, although in this case, we know that our X, so cosine of theta, equals adjacent over hypotenuse, and we do the same process. So 38 times cosine of 310, and to solve for that, we just go over to our calculator, and 38 times cosine of 310 gives us 24.43 is what I'll call that. So we get 24.43 I unit vector. Okay, and then that's just simply our answer, and those together are C. Okay, so that is that problem. Okay, so the next problem says, okay, the next one's a magnitude problem. We already did one like that. Okay, this one's interesting. Okay, it says vector A has a magnitude of 35. Okay. A has a magnitude of 35. B has a magnitude, so B vector, I'm sorry, I haven't been drawing vector arrows, has a magnitude of 20. It says the angle between them is 65 degrees. And it wants to know the magnitude of the resultant vector of their sum. Okay, so if we visualize this, we can define this as the xy axis. And because it only gave us an angle, it didn't give us any tilt or anything, so we know it's simply two-dimensional. So if we call this, I'm going to call this A. I'm going to say A is on the x-axis, but B is an angle 65 degrees, okay? So we know that A is going to be, since it's perfectly horizontal, sine of theta, whenever theta equals 0 is 0, so we know it won't have a y component, but cosine of 0 is 1, so we know that A equals 35I unit vector. But B, it has components because it has the x component and a y component, okay? And to solve for it, it's just simple trig. So that's our 20. So cosine of 65 equals adjacent over hypotenuse. We know our hypotenuse is 20, so we multiply it over there. So 20 times cosine 65. Okay, and if we go ahead and do that, 20 times cosine of 65 is 8.45i, so B equals 8.45i, and its y component, I'm writing a plus because I know it's positive. The y value is positive. It's just simply 20 times sine 65. So let's go ahead and do that. So 20 times sine of 65 gives us 18.13. So we've got plus 18.13j. Okay, and then to find the magnitude of their sum, we simply add up the x's. So we get 35 plus 8.45. So if we go ahead and go over to our calculator, 35 plus 8.45 gives us 43.45. So 43.45i plus 18.13j. And it wants to know the resultant magnitude of their sum. So the resultant is equal to the square root of x squared plus y squared. So that's equal to the square root of 43.45 squared plus 18.31, or sorry, 13 squared. If we go ahead and do that in our calculator, we get, let me quickly go ahead and do this, square root of 43 point, let me double check what that was, 43.45 and 18.13. 0.45 squared and then 18.13 squared plus 18.13 squared, and that yields a resultant of 47.08 units, because we don't have a specific unit here. Hello, okay, I'm back. Sorry, I had to take a quick break there. And I just realized I'm like 12 minutes in, so I really do have to speed this video up. And of course now I'm lollygagging because I don't have my little writing utensil with me. So I'm going to quickly pause the video again while I go get that. Okay, so I've now realized that I am like 12 minutes in, and I really need to speed this video up because, you know, vectors aren't that hard. So it shouldn't be taking this long video. Okay, now to actually get to some dot and cross products. Okay, so our first one says 4k. It wants a dot product of 4k minus times minus 2k. You know, because it's multiplication at the end of the day. Okay, and if we remember, you know, dot product factors in cosine of theta. So it's the amount in the same direction. Since these are both perfectly in the same direction, it will just simply be negative 8. Okay, so let's do that. Next one is 3j, the cross product of 3j and 8i. So 3j times 8i. Sorry for forgetting to do that. Okay, so this, we know that these are perfectly perpendicular, and the cross product of is of perpendicular units. And so we know it'll be 24 something, because 3 times 8 is 24. But the question is what direction, you know, is it positive or negative that direction is it going to be? So the way I remember it, so some people use the right-hand rule, but I find this much easier. So if I write out I, and then j, and then k, okay, if I draw, you know, a quick counterclockwise kind of triangle, what this graph is, or chart essentially tells me, says if I go to j to I, I'm going to get a positive k. Whereas if I go from like negative, or from j to I will get a negative k. So it's like if you follow the flow, you get a positive of the other one you don't use. If you go against the flow, you get the negative of the other one you use. So following this chart, we get negative 24k k unit vector. Okay, on to the next one. We get 6i, the cross product of 6i times 2k. So if we look back at our chart, we're going from I to k, so that's against the flow, so that means we're going to get a negative j, so negative 12j. Okay, our next one is the dot product of 2j times 8k. And the thing about dot products, if they're not in the same direction, or like there's not like an angle, like so these are perfectly perpendicular. So the dot product of this will simply be 0 because dot product only wants the amount in the same direction. And since they're perfectly perpendicular, there's none in the same direction. The next one would be negative 14j, the cross product of negative 14j times 3j. And this is, you know, the opposite of this. So they are perfectly, you know, in the same exact direction. but cross product only wants perpendicular, so this will be 0. So if they're in the same direction, you get 0 because cross product only cares about perpendicular. And then this final one, we'll do 12i, the cross product of 12i times negative 1/2 k. Okay, and so we're going from I to k, so that's against the flow. So we should expect a negative j. However, we're multiplying by negative, so this would normally be negative 6, but negative times that is positive 6j. J factorial. Or not j factorial, j unit vector. If I've called unit vectors factorials in this video, please just know that I meant to say unit vector. I know what a factorial is. It's n to the, that's a factorial. It's like 3 times 2 times 1 or whatnot. But okay, so let's carry on and move on. I'm not going to do sums or whatnot, but however, I will do this next one, and it wants to know the scalar product of a and b. Okay, so a equals negative 4i unit vector plus 5j unit vector minus 2k unit vector, and b equals 6i unit vector plus 2j unit vector plus 3k unit vector. So if you think about it, if we were to multiply these by each other, we do like this multiply that, we'd have to FOIL a bunch. But since we know we're doing dot product and we only care about things that are in the same direction, then the only thing that's going to yield is I times I, 5, or j times j, k times k. So if we simply just do I times I, so 6 times negative 4 is negative 24. Okay, 5 times 2 is 10. And then negative 2 times positive 3 is negative 6. Okay, so we end up with negative 24 plus 10, which is negative 14 minus 6 equals negative 20. And it's a dot product, so there's no units. So yeah, the dot product's pretty nice. It's pretty handy. The next one, it wants the magnitude of that, but I've done a couple examples of that already. It wants the magnitude of that product. That's not bad. It wants the. Okay, sorry, no, never mind. This is different. So it wants the magnitude of the vector product of a and b. So pretty much what you have to do is let me see if I can actually. I messed up. I could have controlled Z that. So I'm going to quickly pause the video real quick and I'll rewrite that and I'll be right back. Okay, so this one wants the magnitude of the vector product or cross product. So pretty much how you do your cross products. If you have your three dimensions, this is how it's going to FOIL out. Okay, so basically what it is, so a times b equals a to the y times b to the z minus a to the z, b to the y times the unit vector of I plus a to the z, b to the x minus a to the x, b to the z times the unit vector j plus a to the x, b to the y minus a y, b x times the unit vector k. Okay, so if we plug these values in, we get, so a to the y, so that's 5, so 5, so I'm going to go ahead and bracket these off, so 5 times 3 minus negative 2 times 2, okay, and all that will be I, plus, I don't know if I'll have enough room. Plus, if I don't have enough room, just you guys know what I was going to do. Okay, so negative 2 times 6 minus negative 4 times 3. And then that is j plus, I'm going to have to go down there, a to the x, which is negative 4 times negative 4 times 2 minus 5 times 6. Okay, so that's what it is. That's our times k. Okay, so it also wants the magnitude. Okay, so we're gonna go ahead and solve for each of these I, j, and k. So to make it simpler, I would normally have to do this and stuff, but since I'm running out of time, I'll just get my calculator to do it for me. So I have 5 So if I go ahead and do parentheses, so 5 times 3 minus, what do I want? Negative 2 times 2 times negative, okay, so it's being really a pain to like work out on this calculator, but long story short, if you plug this into your calculator and you solve for everything, you get that your total units are 19, that 9 was really bad, 19i minus 38k, and if you take the square root of both of those squared, so the resultant or the magnitude equals square root of, in this case, x squared plus the z squared, you get an answer of 42.48 units. Let me just make sure I have all my writing correct. Yep, that's good. Negative 2 times plus 6. Yep. Negative 4, 2, and 5, 6. Okay, yeah. So if you work that out in your calculator, you should get the right answer. I just don't want to do it because I'm already running long on time, and we need to get a couple more. I'll just say one more problem done. This will be the last one. Okay, so it says vector A has the magnitude of 15, so A equals 15. Okay, so vector A, that's an arrow, and vector B has a magnitude of 12. Okay, and it says that A dot B, so the dot product of A times B equals 96. Okay, and it wants to know what the angle is between A and B, so theta. So A dot B can be rewritten as A B cosine of theta. So if we rearrange some equations, we get 96 equals 15, which is magnitude of A, times 12, which is the magnitude of B, times cosine of theta. So we get 96 over 15 times 20 equals cosine of theta, and thus inverse cosine, so cosine, or arc cosine, sorry, of 96 over 15 times 20 equals theta. Okay, so if we go ahead and plug that in, we get for an answer of, so let me do this, of 96 over 15 times 20. We get an angle of, what in the world happened there? Sorry about this. And maybe because I'm in degrees. Here, let me just multiply 15 times 20. Okay, and then do it from there. So inverse cosine of, sorry about this. I don't exactly know why my calculator was giving me the wrong answer, or is giving me the wrong answer. 300. Okay, so that is quite odd. Let me quickly pause the video and I'll figure out why my calculator is doing this. Okay, I'm back. It turns out I'm apparently dyslexic. So the 20 over here is that I'm like, okay, so I'm only dyslexic whenever I go to like read input in my calculator. That's 12. I'm sure everyone watching it was like, no, Matthew, you're just dumb. So this 20 needs to be 12. This 20 needs to be 12. So if we quickly change this up, just quickly select all this. If it will let me. There we go. Control C and Control V, that right there, and turn that into 12, and we get an angle of 57.77 degrees. 57.77 degrees. That last number is 7 degrees equals theta. Okay, so that was this video. Hopefully it was helpful, and yeah, if you guys have any requests, any videos you would like me to make, I will be happy to take requests. We should expect some more videos coming out very soon in calculus, physics, physics C, physics 2, maybe even AP chemistry, so stay tuned. Alright, and I'm out.